કોઈ આવ્યું છે કે કોઈ પીડીએફ કોઈ આવ્યું છે ઓફિસમાં રાજેશભાઈ કોઈ નથી આવ્યું.
Good morning, madam. Good morning.
રાજેશભાઈ આવે ને તો મને જરાક પહેલા મોકલજે ને મારી પાસે.
हाँ रोही है.
Yes, sir. Yes, sir. Sir, I'm here. तो पार्टिसिपेंट्स अभी उतने नहीं आए हैं तो we thought हम लोग 5 मिनट वेट कर लेते हैं.
Okay. Because madam is waiting, so
No
you
problem.
Sir, I think we'll just wait for 5 minutes. सिर्फ 19 लोग आए हैं तो अगर थोड़े और ज्वाइन कर लें तो then
Okay.
Okay, no problem, no problem.
Okay. A very good morning to all the participants. Good morning, ma'am. Thank you for joining us again. I'll be moderating the session today along with Sakiba. My name is Ruhi and I'm pursuing my PhD in Water Resource Engineering from NIT Srinagar. We have Dr. Namrita Jariwala with us today. A very warm welcome to you, ma'am. Dr. Namrita will deliver the lecture on applications of fuzzy logic and fuzzy rule-based system in civil engineering. Dr. Namrita is working as an assistant professor in civil engineering department at SVNIT, Surat. She is having 20 years of teaching experience. She has obtained her bachelor's degree in civil engineering from MS University Vadodara in June 1996. She was awarded gold medals for securing highest marks. She obtained master's degree in environmental engineering also from MS University Vadodara in 1998. She has obtained her PhD from SVNIT, Surat. She has presented many papers in national and international conferences. She has published 8 papers in national journals and 12 papers in international journals. And she has guided 3 PhD students and 21 MTech students. Apart from her academic career, she has handled various consultancy projects of Surat Municipal Corporation and other local government bodies. Her research area interest is in health and risk studies in environmental engineering, air pollution related studies, soft computing techniques, and environmental engineering and fuzzy logic and its applications. A very warm welcome to you, ma'am. You may begin the session. Dr. Namrita?
Yes, you can hear me? Yes.
Yes, ma'am. Ma'am, you can start. Please start.
Yes, I'm sharing my presentation.
Okay, ma'am. Thank you, ma'am.
I think you can see my screen.
Yes, ma'am. Yes, ma'am. We can see your screen.
Okay, thank you.
Thank you, ma'am.
So, first of all, good morning to all dear participants and faculty members present in this session. I'm going to discuss the application of fuzzy logic and fuzzy rule-based system in civil engineering. I hope you all of you have attended the lecture of Dr. Christian. So I know the basic concept of fuzzy logic and fuzzy rule-based system is already discussed by him. I will be discussing some of the theory portion only just for the leading my session. Otherwise, the theory portion I think already he has discussed and he has given a very good introduction. I will be discussing mainly the application of fuzzy logic and fuzzy rule-based system in civil engineering. So, with this background, I will be starting. Now, as you know, and sir has already discussed, the fuzzy logic father is Dr. Loftizadeh of Berkeley University, and mainly it is differ from the binary logic, whatever the mathematics we just considered. So, our binary logic, binary sets mathematics is considered as a 0 and 1. So, you have a some concept and you have only two options, one is yes and second one is no, so you can say it's a 0 and 1. Even I have used the same slide Dr. Christian has discussed so that it may be recalled some of the things whatever he has discussed. So when we consider the binary sets and the traditional mathematics or the traditional algebra, whatever we are considering, so it is based on 0 and 1. Now, exactly what is fuzzy logic? So the fuzzy logic is somewhat different than our Boolean mathematics or the traditional mathematics. So in a fuzzy logic, we have a very good option. So in a Boolean mathematics, as you have a two options here and say no, you have a fully memberships of one or either you have a fully membership of a 0. But in fuzzy logic, you can say your membership will be vary between 0 to 1, and that is why it is considered to be a graded membership. So this is the basic difference between fuzzy logic and the Boolean mathematics or the traditional mathematics, whatever we are considering. Now, the very simple application and why we have to consider the fuzzy logic. So, the very important thing is there are so many problems in our life, or there are so many regular day to day our activity where we don't require the complete information. Only the mode of reasonings will be okay, and that will be enough to consider our problem. So, I think the best example is I will use umbrella if rain comes. So the simple logic is I will not use the umbrella if rain is not coming. So this is considered to be a logical reasoning. So the same type of the logical reasoning, we can use it in our fuzzy logic concept. And this is the beauty of fuzzy logic, that with this type of the reasoning system, you can solve some of the traditional and our engineering problem. So we can say that our knowledge is fuzzy. Suppose I ask, uh, is this child is young. So the very important thing, I am not concerned about the age, exact age, but I am concerned about whether he is young, whether he is a child, whether he is a very young, or whether he is a old age person. So the very important thing is there are so many ways in life where we are not required to go with the exact information. And the same thing, I think, when we are dealing with our research problem, so many times the same situation is coming in our research life, and that is the non-availability of the data. Or it may be possible that the data available, but ultimately that data we are not considered to be a precise data. The data, whatever we are considering, it is not a reliable data. So in that type of the situation, when you have a imprecise data, when you have a not convenient data, and you don't know whether data is accurate or not, but you want to go with your research problem. So in that type of the situation, definitely the fuzzy logic will help you. Now, I'm not going in the detail because I think already it is discussed, but the very important thing is I will be explaining only one slide, and this is very important for us. And what is the difference between the simple thing, simple mathematics, and the fuzzy logic? So, when we consider with the fuzzy logic, we have a fuzzy sets. So, there are two sets. One set that we consider our traditional mathematics sets. So, where we are considering the A set is nothing but it is a height of the person up to 1.8 meter. And second, we just consider as a fuzzy sets where the person's height is up to 1.8 meter. Now, what is the difference if you just consider our traditional algebra sets? So, in that you have a person which height is greater than or equal to 1.8. So, you have a 1.8 meter entry, you have a 1.9 meter entry, and more than that entry. Now, suppose we just consider the person which is having a height up to 1.8 meter in a fuzzy sense. So, up to 1.8 meter means in a first set, if the person is having a height of 1.7 meter, he will not be having an entry in this particular set, because our set is algebra sets where we do not have a graded membership functions concept. But when we have a fuzzy sets, the person whose height is up to 1.7 meter, you can see that this is 1.7 meter, and if you just draw the line up to it, you are getting zero point 0.8. So in that type of the situation, when we are having a fuzzy sets, we can consider that the person having height of 1.7 meter is definitely will be there in the fuzzy set, but his belongingness will be only 0.8%. So this is the main concept when we are dealing with the fuzzy sets. Suppose if you just consider the person who is having a height only 1.55 meter, so that person is also getting the entry in the fuzzy set, but his belongingness will be very less. So this is the main thing when we are considering our fuzzy set theory. Now in a fuzzy sets, I think this is already discussed. I am not discussing. When we are using the concept very low, low, medium, high for representing any variable. So this is considered to be a linguistics variable. Now we will be going with the decision making problem. Now, when we are considering the decision problem, so the simple example is of our day-to-day life, and the similar type of the problem we utilize in our engineering problem, means our research problem. Now, suppose simple, I want to select a car. I have a three options. means selecting a car, it is my aim or objective or it's a goal. So it will always come on the topmost side. Now, then I have some criteria. The cost is a criteria, style is a criteria, reliability is a criteria, I require mileage of the car. So these all are the criteria of my selecting car. So when we are considering the criteria, it will be on the intermediate level or it will be on the second level. So first is a goal, second one is a criteria, whatever we are deciding for our problem, and third is the options or whatever the indicators or the solutions option we are considering for this. So suppose I may select this Scorpio, Duster, these all the cars. So that is my options or the alternative. So that will come on the lowest side or the lower side. So first is a goal, second is a criteria, and third one is a option or the alternatives. So always our decision problem will follow this hierarchy. So whenever we go with a decision making problem, I think all of you have heard about the multi-criteria decision making problem, fuzzy multi-criteria decision making problem, MADM, multi-attribute decision making problem. So whenever we consider any type of the problem, we have to deal with this type of the concept. Now we are discussing the fuzzy rule based system, and this is nothing but it is our decision making system, but where we are utilizing the concept of fuzzy rule based system. Now when we deal with the fuzzy rule based system, so the example is of smart air conditions, whatever we utilize in our day to day life. So our smart air conditions are having a fuzzy controller in the system, and this fuzzy controllers works on the same concept. So there are some of the set of the rules fixed in the controller. So if the temperature is very cold, then stop fan. So depending upon that, there are some keys available. Fuzzy controller keys are available in the remote, and then we are operating. So the our so many applications right now, our electronic devices are working on this particular concept. I think you all of you have experience of the washing machine. So washing machine, whatever the fully automatic washing machine we are utilizing, top loaded or front loaded. So in that also the fuzzy controller programming is available. So the cycle of washing clothes will be selected based on the functions whatever you are selecting. So we are not knowing, but there are so many fuzzy applications we in our day-to-day life we are utilizing. Now, this is the simple examples of our civil engineering project. We just consider if project duration is long and project staff is large and project funding is inadequate, then the risk is high. So I think up to this, whatever the similar concept I have discussed, I have taken 5-10 minutes for just explaining my portions very thoroughly. Now, the very important thing is we are dealing with a fuzzy rule-based system. So in a fuzzy rule-based system is nothing but it is the joining of your input parameter with the output parameter with some of the operators. So this is considered to be a fuzzy controller. So in a fuzzy controller, we have a 3 steps. So mainly first, it will be dealing with the input variables. So for any problem, it may be a civil engineering problem or it may be a simple our day-to-day life problem. First, we have to consider the input variable for the problem. So we have to select first input variable, and then second very important thing, we have to define that particular input variable on a fuzzy scale. I'm coming to that particular point. Now, the second very important thing is you have to deal with the output variable also. So you finally at the output, whatever you require, that also you have to define. So input and output variable, and then you have to define it on the fuzzy scale. That is the first step of our fuzzy rule-based system. Now, the second step is you have to join your input variable and output variable with some of the functions. Now, you can use AND function, you can use OR function. So, you can connect your input variable and output variable with a AND operator, or you may connect with a AND operator. Now, in a day-to-day life, whatever we are utilizing, the same concept, logical reasonings, we have to use it here. So, whatever is our input variable, depending upon that, we will decide whether we should go with AND system or with OR system. Now, so the second step is you have to join your input variable with the output variable, and that is with a that is considered to be a rule portion. So once you have all the rule, all the conditions, depending upon that, the rules will completely fire, or there will be a partially fire, there will be aggregations, means defuzzifications operations, and finally you are getting the output. So this is the simple logic of fuzzy rule based system controller. Now, this fuzzy rule-based control system operations, you may perform it with manual whenever we are working with a multi-criteria decision making. So you can take the help of the AutoCAD, and with the help of the AutoCAD, you can generate the defuzzifications operations, and you can generate your final output. Second is, if you are knowing some computer programming language, then you may select fuzzy composite programming or the fuzzy linear programming, and based on that, you may consider the uh, your selections of the input and the output methodology. And the third and very important and the very simplest method is you can use the fuzzy toolbox, and that fuzzy toolbox is nothing but it is a MATLAB fuzzy toolbox. So in a MATLAB new versions, the fuzzy toolbox facility is readily available, and with the help of that, you can use the concept of fuzzy rule-based system very effectively. Now, I'm just discussing one simple problem that is nothing but the tipping problem. So, that is nothing but it is our day to day life problem. And after that, I'm coming to a civil engineering problem. Now, the very simple problem is whenever we take the food in any restaurant, so what we consider the quality of the food, and we just consider the service given by the restaurant. And depending upon that, generally, this is the general or the Indian tradition that we just give some tip to the waiters. But the very important thing is definitely our tip will be limiting to our whatever the meal, whatever we are considering. So here the simple this particular problem, I think we all have observations. We all have enjoyed this, and if we are trying to solve this particular problem with a fuzzy logic and fuzzy rule based system concept. So this is just for making my civil engineering application simple. I am discussing this particular problem. Now we may consider the service in three variables. You may scale the service of the particularly the food and quality of the food on a three scale. You may have a poor, good, and excellent. So your service may be very poor, it may be very good, and it may be excellent service. You may receive excellent service. And for quality of the food also, you may have a two option. Quality is very bad, and quality was is very good. And depending upon that, you may consider the output variable. So you may give very cheap tip, you may give your average tip, and you may give a very excellent tip to this particular restaurant waiters. Now, this is the simple problem. So I can define the term like a poor, delicious, cheap in a particular fuzzy scale. The second very important thing is we have to consider the connectivity of the input and output, and then we have to put all the rules whatever we are considering for our problem. Now here the very important thing is we may consider if service is poor then tip is cheap. So this is one my assumptions. I just consider the rule accordingly. If service is good, the tip is average. If service is excellent, then tip is generous. And if food is rancid, then tip is cheap. So, like that, I have considered based on my assumption, based on my perceptions, I have considered some of the important rules. Now, the second very important thing is we may consider the similar type of the rules. So, here I can consider some other rules like two instead of five, only three rules. So, if service is poor or the food is rancid, then the tip is cheap. If service is good, then tip is average. And if the service is excellent and food is delicious, both the thing is good, then tip will be cheap. So this is whatever the idea I am having for the tip that I have put up on a logical reasoning term. So the very important thing, this logical reasoning is a very important part because it will join your connectivity between input and the output variable. Now, the very important thing is I have to define the input variables. Now, for defining the input variables, we have to consider the range of that particular input variable. Suppose we are dealing with a civil engineering problem. Suppose anybody is working in civil engineering problem and they are considering the rainfall as one of the important parameters. So in that type of the situation, you are knowing the particular for whatever the basing you are working. So if you are knowing the typical range of the rainfall considering the 100 years data, then that you can reselect that particular range of that particular input parameters. Now the second very important thing is you have to consider the anyhow you have to define your input parameters on a fuzzy scale. So the very important thing is either you know the range of that particular parameters or you don't know the range of the parameter. Suppose service, the service of the restaurant, then you don't have some scaling for that. So the simple concept is you can prepare the Linkart scale. So you can give the weightage. So depending upon the weightage, you can range or you can rank that particular service. So it's our simple assumption is 0 is indicating the poor service, 1 is also towards poor, and the higher rank will be giving you a excellent service conditions. It represents the excellent service condition. So the similar thing is for the food also. So lower side will representing the poor quality of the food and the higher side will be representing with the excellent service. Now at the same time, I have considered the output, and for that output I have considered maximum I can give up to 25%. Even you can select lower than that also. So the tip will be whatever is 5 to 25 percentage of the bill. So what I have done, I have defined my input parameters and I have defined my output parameters. Now the second very important thing is the rule. So I have defined some of the rules, whatever I have considered. So the logical rules I have put up in a rule editor. Now how to put up in the rule, so that I am discussing also later on. Now these rules I am considering and I'm putting, and ultimately my first step, that is a defining the input parameter is considered, and second one is defining all the rules in the rule editor, that is over. Now after this there will be aggregations of all the rules, and from the aggregations of all conditions, rules are nothing but it is the condition. So whatever the conditions you have given, so based on that particular conditions, your, and at the same time you have a value of your input service, and based on that your rules will be completely fire or it may be partially fire. So ultimately you have a three conditions because you have put up three rules, and aggregations of these three conditions will be the operation considered as a defuzzification operation. Now, this defuzzification, there are so many methods available, but generally we are considering the center of gravity method. So, with the help of center of gravity method, so defuzzification is what? So, considering your three conditions, you will be having the aggregations of that particular conditions, and you are getting only a single value, that is a Cripps value. So, ultimately, you are having a fuzzy value, and then fuzzy value you are converting into the Cripps value, because output, as a output we require one single value. Once we have a single value, then and then you can go ahead with your output problem. So this is a simple network that we have built up in a fuzzy controller system. Now you may define the fuzzy input variable as a variety of the conditions. I'm coming to that particular point in the second problem. You just bear with me because here I have defined, this is the problem where the delicious food has been defined with some trapezoidal membership functions. I'm coming to that particular point also, how to define the membership functions. So when you are having the very good condition, that is a food is delicious. So in that type of the situation, you can represent your conditions of the food in a different way. So that is nothing but it is you're defining the input parameter. Now the one is a service also, so you can define your input parameter and you can define your both the input parameter. Now for defining the input parameters, we are utilizing the link membership functions, and the shape of the membership functions you can select as a trapezoidal, you can select triangular membership functions, you can select even Gaussian membership functions, you can select sigmoidal membership functions based on the applications and the variability of the parameters. Now, the very important thing is first you have to define your input parameters, whatever is the input variables you are having, and at the same time you have to define your output parameters also. Now, you may have a when we are considering the input part, it is considered to be an antecedent part. and your output part, that is nothing but is your implications parts or the consequent part. Now, the very important thing is you have a three rules, because I have considered three rules. So if the food is poor, if the service is poor and food is also cheap, so in that type of the situation, I will be giving a tip cheap. If my service is good and at the same time my the quality of the food is also good, so in that type of the situation also I will be giving average cheap. And if my service is excellent and food is also delicious, then in that type of the situation I will be giving a generous, somewhat deep on the higher side I'll be giving. So once I will be having this particular conditions in the controller, so I may use the fuzzy composite programming or I may use the MATLAB toolbox, and then I will be having these three conditions. I will be having aggregations. So this is one condition, this is two conditions, and then three conditions. So aggregations of this, I will be giving this particular area. So this is the area of a particular of this particular conditions. Now I will be having aggregations of this 1, 2, and 3. So ultimately, finally, I will be having a aggregations area like this. And for a defuzzifications operations, means in the particularly for these operations, we may select two methodology. One is a Mamdani, and second one is a Sujono operation. But Mamdani and Sujono operation, these both operations are having their own limitations. So generally, Mamdani is a very powerful tool that we can use it for all the type of the general problem. And generally, Sujono methodology that make it that we may use it for the non-linear programming type of the problem. So we will be having aggregations, and if we go with the centroid method, then you may get the output, and that is nothing but it is a tip that is equals to 16.7%. So like this, you can finally, whatever is our problem, that you can define on a fuzzy scale, and then you can get it output. So the idea is you are not having any data, you are not having any convenient data, only the idea whatever in your mind that you have converted onto a scale, and then you have find it out the solution. So the simple problem of fuzzy logic is working on the same concept. When you have no precise data, when you have irregular data, when the data for which you are not having confidence, we can use the concept of fuzzy logic for our engineering problem as well as all our day-to-day life problem. Now, the very important thing, I will be just giving you some introductions of the fuzzy toolbox. So this fuzzy toolbox, this is a very, you can say it's a smart toolbox of the MATLAB. So once you open the screen of the MATLAB, and if you write just with a 2/fuzzy, then your fuzzy screen will open. So this fuzzy toolbox is the ready toolbox available in a MATLAB, and generally whatever the operations we have discussed in our TEEP problem, so that you can define it with the MATLAB fuzzy toolbox very easily, and you can solve the problem. You can take the help of the computer and you can solve the problem very easily. Now generally it is a GUI tools considered. So GUI is what? It is a graphical user interface. So once you open your fuzzy toolbox, this type of the editor will be available, and this is considered to be a FIS editor. Now in the second functions, you have a membership functions editor, and in a third functions, you have a rule editor, and in the fourth functions, you have a defuzzifications operation. So whatever the operations we have discussed here, so this you can do it in a MATLAB toolbox very easily, and this toolbox is very simple. It's very user friendly, and you can do all type of the problems, and variables of input variables and output variables in a MATLAB fuzzy toolbox very easily. Now, once you open your fuzzy editor, so you will be getting this type of the screen. So in which you have to first select the whatever is your input variables. Now, instead of if you are having two, instead of this you are having three variables, then also you can add variables. Even in output also you can select variables if you are having more than one. The second very important thing is the methodology also you can select. So suppose if you go with a Mamdani, or as I have discussed, you may go with the Sujono, then also you can select it here. Now the methodology, there are in a defuzzification operation we have so many methodology. so that you can change it here if you want to change it. And the very important thing is you can give a range of the variables if you are interested. जहाँ पर हमारे पास means whenever we have a range of the variables that we can define the variables range in a this particular system. Now the second, that is a membership functions editor. You can see here in this for a functions variable service, we have a linguistics variable like a poor, good, excellent. So here you can select whatever is the membership functions you want to select and the save. So you may select, you just see here triangular membership functions, then you have a trapezoidal membership functions, you have a Gaussian membership functions. So all type of the membership functions you can select and you can change it from here. So whatever we want to do it manually, it's very difficult, but you can do it with a fuzzy toolbox very easily. Now, second very important thing is you want to change the range. Then also you can change the range from here. So these all the things you can do it very as easily with a MATLAB toolbox. Now the second very important thing is all the things you can change it as is required and you can edit it as per the function. Now the very important thing is the rule. How to add the rule? So for that the step of the window will be available and you have to, there will be two variables. So because we have selected one service and second one, that is a food, and output variable is the T. So whatever is your service, so you have selected three linguistics variables. So this is poor, good and excellent, and here two. So at least you can have a 3 into 2, that is equals to 6 rules. But out of this 6 rule, I have only selected these 3 rules because this is the logical reasoning I am knowing, and based on that I have selected. So I will work with the system only with the 3 rule. But suppose I want to add the rule, then you can see here delete rule, add rule, change rule, all the functions available. So you can make the change in the rule very easily with the rule editor. So rule editor is a very important function, and based on this, your final output will be there. So the very important thing, you have to consider all the rules very logically. If you put wrong rule here, then there will be a wrong fire of the rule, and that will lead to the improper solution. And that is why your rule editor is a very important. It's a heart of your system. It's the heart of your system. Now, once you can change this rule, yeah, and as per your need, you can create, edit, delete. You can do all these operations very easily in the rule editor. Now, the next operation is a rule viewer. This is nothing but, as we have considered three conditions, you can see here three conditions. Now, I have given this red line because I have selected input as a 3 and 8. So, once I am changing my service as a 5 and food as a 5, then this line will shift. So based on the conditions of the input, the rule will be fire and there will be aggregations of the area depending upon the three conditions where my input variables are falling. So once I have these three conditions, I will be having aggregations of these. I will be going for the center of gravity method, whatever I have discussed earlier. But these all the operations will be done by the MATLAB programming, MATLAB fuzzy toolbox itself. And finally, you will be given TEEP as a 14.8 is the output. So once you are selecting service as a 3 and food as a 8, you will be getting outputs as a 14.8. Now, if you change your input, suppose 5 and 6, then definitely according to this, your TEEP value will be changed, your output will be changed. So these all the operations you can do it very logically in a fuzzy toolbox. So this is the really help available nowadays because many researchers are interested to work with a fuzzy and they don't know the fuzzy linear programming or the composite programming or any Unix or the basic whatever is required for the programming. So instead of that, if you can directly use the fuzzy toolbox available, because generally MATLAB is a very user friendly software and nowadays it is available with a majority of all the institute. So you can change according to your input variables whatever you are interested. And finally this viewer will give you the idea regarding your input and output, and it will be representing your two-dimensional and three-dimensional output conditions. So depending upon that you may change the things. Now this is the second problem I am dealing, and this is again a problem, and I think you might be knowing right now the corona problem is there. So suppose I am not having any data, I am not having any idea in my mind. Now we will be discussing that we are just want to determine the risk of the getting corona disease infections. I am not knowing what is the conditions, what are the personal hygiene of the people, or what are the food they are consuming. But simple, as a general, as an engineer, as a technical person, I know the age of the person is very important, and BMI. BMI is nothing but it's the body mass index of the person. So once you are having a data of age, because what we are doing, what we are considering. So in our day-to-day life, we just consider the teenage age. So after teenage age means after 16 years, generally it is considered, or it is assumed as per the medical science, that all your system of the body, like a respiratory, then neurological systems, all the systems are completely developed. But before teenage, it is in developing stage. So as you are in a developing stage, you have a more chance to get the disease infections. And once you are completing 50 and 60, you are in a risky group to get all the disease, because your immunity will be decreasing with the age. पूरा body का deterioration चालू हो जाता है. So this is the one criteria. This is the simple consider. I have considered the parameters because I am not having any idea how to select the input parameter. And the second, that is a body mass index. So body mass index is representing the my complete style of the body. So it is the ratio of my body with respect to the height and weight. So you may consider this is a cardiovascular disease, or it may be a respiratory disease, or it may be a corona disease. Your age and BMI is a very important basic factor to get the risk diseases. And these are the influencing parameters as far as the risk of the disease is concerned. So what we are trying, with the help of this age data and with the help of this BMI data, I am trying to find it out the risk. What is the possibilities to get the risk of the diseases? So we are totally blank. We don't have any data, and we start with the utilization of the fuzzy concept. Now, how to deal it? So the very first very important thing is the first, that is the input parameter age. Now this input parameter age, I have to define into the fuzzy sets. So the very important thing is how to select this uh, input variable, and how to decide these 1, 2, 3, 4 fuzzy sets I have considered here. The second question you may have in your mind, why to select trapezoidal, where to select triangular, and where to select this type of the combinations, यहाँ पर overlap, why to select overlap. So these all the questions you may have in your mind. So the first very important thing is the whatever is the parameter I have selected. So the first you have to select the range of that particular functions. Now here you can see on the x-axis, in x-axis I have considered the age of the person. It is starting from 0 to 100, because in our day-to-day life we just consider maximum up to 100 years. So I have selected the same thought, 0 to 100 years is the range of the my input parameters age. Now, y-axis will be a fuzzy scale, and that is why in a y-axis you have a 0 to 1 scale. Now, the very important thing is how to select. So generally, you know, age, as I have considered the linguistics variable, and this linguistics variable we know up to very young means up to 0 to 20 years. 20 to 30 years you may consider as a young, and middle age means up to 50 years, and more than 50 years we may consider as an old person. Now, here you can see here I have considered the membership functions of the linguistics variable, two type of the linguistics variable functions. So one, that is a triangular. You just see the young. So for this young, I have considered the triangular membership function. But if you just see the very young, I have considered the trapezoidal membership functions. For a trapezoidal also, you may have a two type of the trapezoidal. This is the closed trapezoid, and you may have a open on one side. That may be possible in some of the cases. Now, how to select? So here I have referred one of the, because actually right now many people are working, even the medical people are working also in a fuzzy logic and fuzzy rule based system area, and that is why in one of the paper I am getting the reference how to select the age as an input parameter. So I have selected directly this particular from this particular reference, whatever I have mentioned. But the very important thing is how to select. So for that, in that type of the situation, what you can do, you don't know the range. Okay, so in that type of the situation, what you can do, Definitely, you can take the help of the expert. So, how you can define the help? How can you take the help of the expert? So, now the very important problem is you are somewhat knowing about fuzzy, but your expert is not knowing about the fuzzy. So, in that type of the situation, what you can do, you can define your linguistics variable, but ask your experts regarding the range of the linguistics variable. So you may ask the expert, suppose the expert I have selected as a doctor, then I can ask the doctor, what is the general age? You may select it as a very young or young. So like that, you may have a opinion or the expert's opinion. And in that type of the situation, it will be only help you to lead your problem. Now, the second very important thing is the only one expert is not enough. So generally, for that, those who are working or those who are interested in working, so I think you can refer a very important paper, and paper name itself is Magic Number 7. So Magic Number 7, in that particular paper, the concept is given. They have the author is SETI, and SETI has selected the some 7 contractor, and he has introduced some methodology how to select the experts in any multi-criteria decision making problem. So the very important concept has been given in that particular paper, and you can refer the concept and the methodology whatever is discussed in that particular paper. So the idea is minimum you require 7 experts whenever you are selecting, and then opinion will be vary, opinion of the expert will be definitely vary. So in that type of the situation, what you have to do, you have to go for the normalization of the range or normalization of the opinion given by the doctor or the expert. Suppose if you are working in civil engineering, then no need to take the opinion of the doctor. But in that type of the situation, you may select the expert as a some of the consultant or the government officer, those who are working with irrigations or the hydrology department. So like that, we have to consider. Second very important thing, when you are having a triangular membership functions, you can see here the table below where you can see the second row where I have represented with a young. So when you have a triangular membership functions, you have to consider the 3 fuzzy numbers. So you triangular membership functions will be always represented with a 3 fuzzy numbers, and uh, you can see here this is 15, then this is the middle of young is 35, and this is 55. And at the same time, you have to consider the trapezoidal membership functions with a 4 fuzzy numbers. 4 fuzzy numbers. So generally, majority of our civil engineering problem, we utilize triangular and trapezoidal membership functions. Generally, electrical engineering and electronics engineering input variables are following under the range of sigmoidal and all these functions. Now, the second, that is a body mass index. So generally, our body mass index will be vary. I think if you concern any dietitian, so they will inform your body mass index will be vary between 18 to 30 or 18 to 32, and whatever the linguistics variable they are using, same linguistics variable I have used it. Definitely these I am getting from one of the reference. So that is a one, that is a underweight. Second one, that is a ideal, and second one it is overweight, and fourth one is a obese. So underweight means with respect to height their weight is very low. Normal is means ideal, or the normal means with respect to your height your weight is very effective and regular. Overweight means with respect to your height your weight is somewhat on over, somewhat on higher side, and obese means it is a very very higher side. So again we are utilizing the linguistics variable. So the same thing I have considered, the range also I have considered referring some literature, and I have defined the linguistics variable with the help of the experts. So the range, for that there are 2 options. One, you may get some of the reference, and if you are not getting, then don't worry. So in that type of the situation, definitely you may ask the expert, you may take the opinion of the expert. Sometimes students, what they are doing, so they become themselves as expert, because generally experts are not giving the time. Generally academicians, they will give time, but the people working in government bodies are the doctors. If you consult them, they will always give you a time. Okay, you come after 2 days, 3 days, ऐसे ही करके generally um, time is passing and we are not getting the opinion. हमारा ultimately our work will disturb. So what we are doing, we just become ourselves as expert, but it is not good. Sometimes it is a risky. Now, the input variables I have defined. Now, the very important thing is I have to consider the output variable. Now, I am not having any reference, but I have considered in mind, okay, up to 30% is considered to be a lower risk. 30 to 65 percentage or 33 to 65 percentage may be considered as a medium range, and above that I have considered high risk. Now here I may consider the triangular membership functions also. Okay, so the very important thing is just this is because the simple for explanations I have considered, and that is why I have considered here trapezoidal membership functions. The second very important thing I have a clear cut idea in my mind. Suppose two experts are saying that no, up to 0 to 25 is low opinion, and second is saying that up to 20 to 40. So your 0.2 to 25, that is the overlapping range between the experts. So in that type of the situation, your overlapping portions will come. But here I am having my very clear cut idea up to 30% is very low risk. So that is why I have considered like this. So this is the FIS editor rule function is over. I have defined the input and the output variable. Now what is the situation? I have considered for age as a 4 input variable, and I have considered BMI as a 4 input variable. So I will be having a 4 into 4, 16 conditions. So I will be having a 4 into 4, 16 conditions. So I have put up all 16 conditions one by one here. So what I have done, I have considered, I have joined the rule, I have added the rule like this. If my age is very young and BMI is underweight, my risk is low or the medium. So risk is medium, how to consider? So you have to consider the two things. Here also you may take the help of the opinion of the experts, but generally experts are very busy person, you know. So generally for each and every operations, you can't expect their help in your study. If you are getting some expert, they are always ready to help you, then it's a very good part of your study. Now the very important thing is I have selected just if age is very young. So the system is in the developing stage, and even BMI is underweight. The uh, height and weight is under limiting factor. So in that type of the situation, because पूरा system develop नहीं है, so the risk to get the risk chance is a medium. ठीक है? So like that, we have to consider logical conditions of all, and then I have put up all the conditions. You just see, I have considered 16 conditions. So 1, 2, 3, 4, 5, 6. Now it may be possible that if I just consider 8, some of the rules, you just see here first, it will not fire, because according to my data, this particular, I am not having any data which will be pertaining to this particular rule. So like that, I will be having a 16 conditions. Once I will be having the data, according to my input data, some rules will be fired. You can see here, this is the 5th or 6th condition. This is the 10th conditions. So 6th and 10th aggregations of these. Finally, you can see the red line that is indicating the risk. So if your age is 50 years and BMI is 20, so if your age is a middle age and if your BMI is very good, it is towards ideal, then you to get the risk is very low. To get the chance of getting disease risk is very low. So like that, you can have a defuzzification process and you can find it out the final output parameter as a risk. So this is a very important operations that you can do it. You were blank, but you have started your problem with the expert's opinion. You have taken the opinion of the experts, and finally you come up to the output. Now this is the civil engineering problem I am discussing. So first, I think you have come across the simple tipping problem, that is a generalized problem. So anybody can consider that simple logical reasoning. Second, that was related to our diseases risk. Whenever we work with any health related study, so you can work it with this particular conditions. So generally, I love health related studies as far as the environmental engineering are concerned. So that is why I have considered the simple problem, and this is the simple civil engineering problem. So where we have considered the pipe condition assessment of the Surat city, and that is with respect to the southwest zone. So I have considered the data of one zone, and I have considered the number of leakages into the pipeline, and based on that I have just considered the pipe conditions characteristics, means assessment, means whether it is a risky or whether it is a normal or like that. So just we will see this particular problem. So this is a civil engineering problem where we are dealing with a pipe condition assessment. Now, if you just consider the pipe condition assessment, there are so many factors to be considered. So here also we will be considering the pipe age. So if age means if the age of the laying of the pipeline is more than 20 years, then definitely the carrying capacity will be decreasing, and because of that you may have a more puncturing into the pipeline. Second, that is a diameter. So your diameter will be vary from very small diameter to a very large diameter, and depending upon that, the flow will be maximum to the minimum. So that is the second condition you may consider. The length of the pipeline will be very long. So in that type of the situation, also we may consider the leakages into the pipeline. Your thickness of the pipe and operational pressures, this is also a very important factor. Third one, that is a traffic condition, because this is also very important as far as the Indian conditions are concerned, because generally in India, laying of the pipeline on a main road means on one side we will be having a water supply line and other side we will be having a drainage line. So in that type of the situation, your the road conditions will also playing a very vital role. And the third, that is a very important, the next parameter that is very important, that is the depth of installation. So you just see, I have considered for finding out the number of leakages. My output is a number of leakages into the pipeline. Now I have considered 1, 2, 3, 4, 5, 6, and 7. So actually there are so many factors, but only the factors which are responsible for the leakages, what I can measure and I can measured on a fuzzy scale, and maximum they are effective for the output variables that I have considered. Now, the very important thing is why this problem is to be considered with a fuzzy logic. So I think particularly I think if I say that we as a Indian people, we are very poor in a data management, then it's a right statement. Why? Because if you just see any urban authority, and for any urban authority, you may ask the data of the hydraulic system, hydraulic structure and the system, or the complete pipeline network. So they will ask, oh, this particular zone pipeline was laid in 1967, and we do not have a data of that. Because generally in India, there are some of the areas where we have a pipeline more than 100 years old and it's working well. So we don't want to replace that particular pipeline. So generally, the how to manage the leakage, for that, generally the urban authority, they don't go with a smart system. But generally, some leakage inspectors will be available. So if you are having a complaint that you are not getting the enough flow at your home, then you will start complaining to the authority. Authority will send that particular leakage inspector to your place. They will visit and they will write a complaint. And particularly from where your length of the pipeline starts, so they will excavate and they will check whether there is a leakage in between or not, there is something wrong or not, but they don't have any database. So the very important thing is, and the very, I think you will be surprised to know, when we consider at least 1 kilometer pipeline, there are so many pipelines we have seen in some of the Indian cities where the puncturing or the leakages are more than 10. But then also we are utilizing the same pipeline, and that is why we just consider 50 percentage of wastage in our system. So 50 percentage of our drinking water is wastage because of this type of the leakage system, because we do not have a proper data, and that is why urban authority is not properly managing this particular system. Now, the very important thing is I have selected some of the input parameters as I have discussed. There are so many other parameters also that may be influencing the system, but I have considered this particular parameters because the data or the range is also required, and whatever I considered feasible, that I have considered into the system. But the very important thing is you have to consider at least all the maximum influencing parameters of the system. मुझे निकालना है leakages. So for the leakages, whatever is the influencing parameter, that I have to consider. अगर if I consider all the leakages, I am developing the model for finding out the number of leakages, but I am not considering the pipe age. So that is not a good system. You have to consider all the influencing parameters. Now you just see, I have considered 1, 2, 3, 4, 5, 6, and 7 parameters. So if I make all 7 parameters in a fuzzy system, now it will make my systems very complex, because ultimately I want to work with a fuzzy toolbox. So fuzzy toolbox will say not, fuzzy toolbox will allow with me for 7 input parameters also, but it will make my system complex. Fuzzy itself is a complex problem, and you make them again complex, then ultimately you will not get easy solutions. So we require to use the fuzzy logic to just make our complex problem simpler. So that is why what I have done, I have divided intermediate the parameters. So what I have considered, so 1, 2, and 3 input parameters. So I have considered one system, and that I have considered as a physical parameters or the physical factor. So these two importantly I have considered, and that I have considered as a operational parameter. And third one, that is a traffic and depth of installation, that I have considered under the influence of the environmental parameters. So now instead of 7, I will be considering finally 1, 2, and 3, aggregation of these three. And from this physical factor, operational factor, and environmental factor, I am trying to finding out the leakages. Now we will just see how we are working. So I have utilized some of the data. So data, that is a TP scheme. TP scheme means particularly in Gujarat we have a town planning scheme, and I have used data, a map of the town planning scheme of the AutoCAD map, and then I have considered the data of the water distribution network. So where I will be getting the diameter of the pipe. So I have a segment, and from that I have considered the diameter and the length of the pipeline. Now, the first very important thing is how to define the input variables. Now, I am not having any reference material available like I was having in age and BMI. So, in that type of the situation, I have taken the help of the expert. And with the help of the expert, so experts may be a hydraulic engineer of the urban authority, then the academicians and the consultant working in the with the water supply and the sewerage project. So according to that, they have considered that 0 to 40 years is the only pipe age we have to consider. So after 40 years, definitely we have to go for the replacement of the pipe. And that is why I have considered the range according to the expert's opinion up to 40 years. And you know, I have considered the linguistics variable here, triangular membership functions. And again, I have divided into 3 parts: new, moderate, and old. Now here also very important, you just see here red and black line. So this is intersecting. So how to select the intersections? So here again, I have taken the opinion of the experts, and I have asked what will be the new, the range for the new pipe if we consider. So in that particular situation, when I'm getting the combined opinion, okay, 0 to 10, or some of the persons are saying up for moderate also 5 to 10. So in that type of the situation, some portions will be overlapping because this is the opinion of the two experts that is overlap. And that is why I have considered like this. Now you just see, I have considered up to fuzzy number 40 because my range is up to 40. So this is the linguistics variable I have defined with the help of the expert. So the similar thing I have defined for the pipe diameter, and it is up to 750 because I have considered up all the networks, small diameter and the main line also I have considered. And that is why up to 750 millimeter I have considered. So this is the pipe diameter, and again that is with the help of the expert, and the triangular membership functions has been defined. Now, the length of the pipeline, I have considered up to 350 because this is also according to the expert's opinion. So, that is defined as a length of the pipeline. So, my 3 variables will be giving me one again variables. Now, this is first I will be defining all input parameters. Pipe thickness is up to 16 millimeter because generally in India we have a situation up to 16 millimeter. You can see here the varieties of the opinion were merging, and that is why I have selected the expert's opinion like this, overlapping. We may have to consider the operational parameters up to 3 kg per meter square or the Newton meter square. Now you just see the type of the traffic. Now generally type of the traffic is very difficult to manage, and very difficult to manage it on the scale. So that is why I have considered the expert's opinion, and this is on the ranking scale. So I have considered up to 0.3. This is considered to be a heavy traffic. Up to this is a moderate traffic, and up to this is a low traffic. So you may select even according to the opinion whatever you are getting. Now the second very important thing is the depth of the installation. Even for the depth of installation also I have considered the opinion, and according to that I'll be varying. Now I have to select the physical factor, operational factor, and the environmental factor. Now these factors actually I'm not having any idea. So what I have considered, so physical factor means if it is a physical factor is up to some extent, we may consider it's a very risky, adequate, good, and excellent condition. So this is again based on the opinion and based on the experts' perceptions I have defined. So like this physical factor, operational factor, and then I have considered the final output variable as a leakages. So if in the pipeline up to 2 leakages, this is considered to be excellent conditions in India. So you may have a leakages per 100 meter or the 500 meter up to 6 leakages. You may consider good, and up to after 6, it's a moderate risky and very risky condition. So you may define this type of the scaling with respect to the experts when you don't have a other system. Now I have considered the rule. So this is the rule for the pipe height, diameter, and length of the pipe, and from that I will be getting the physical factor. So like this, I may add all the rules for the physical factor, environmental factor, and the operational factor. And finally, from these three, because once you have a physical factor, so from this physical factor, operational factor, and environment factor, again you have to run your system. So I have operated fuzzy rule based system twice. So once that is for getting the physical factor, operational factor, and environmental factor, and then combinations of the physical factor, operational factor, and the environmental factor. So likewise I have considered my the system, and I may get the physical factor, like you have a particularly pipe age, pipe diameter, and length of the pipe. So you may get the physical factor, because generally physical factor is very difficult to as such measure. So what I have considered, I have considered the fuzzy rule based system with a pipe age, pipe diameter, and length of the pipeline. Same thing I have operated with operational factor, and once you have a pipe thickness and operational factor, you may go with this particular system, and you have a operational factor. Now, the third one, that is a environmental factor. You may have a traffic, and you have a depth of installations, and you may have an environmental factor. And once you have a physical factor, you have an operational factor, and you have an environmental factor, you may find it out the number of leakages into the system. Now, here, this is a very important thing, because why I have considered first physical factor through fuzzy logic. So, the very important thing is why I have considered this particular system. So first I have made with this three one system, and I obtained physical factor with a fuzzy logic. Then again with this two I obtain a fuzzy logic, and then again, because if I'm not doing like this, then what will happen? My rule will be like this: if pipe age is long, if pipe age is new, and pipe diameter is long, and length of the pipe is this, and pipe thickness is this, and operational pressure is this, then this. So ultimately, my rules are becoming more complicated. What will happen? MATLAB will understand whatever MATLAB will understand, means MATLAB will operate all the rules, and definitely by first defuzzifications, it will be you will be given some output, but that output is not. It will be a very complex output, because you are difficult to understand. Why you are difficult to understand? Because you have made the system more complicated. So, but instead of that, if you have a 3 or 4 physical means input variables, then with the help of that, the logical rules, you can adjust it very easily. So the simple thing is, when you are asking the experts again, your information should be very clear, so that your experts will help you. Otherwise, how the experts will help? So like these, you are able to find it out the number of leakages into the system. So ultimately, with the help of the data, it is very difficult to predict. And This is the easier way. With the help of this, you can find it out the number of leakages into the system. So finally, from this type of the modeling, I have considered total 493 sections and 62.5 kilometers long line into the particularly in this particular TP scheme. 62.5 kilometer long lines has been analyzed, and from this particular pipeline, so totally I have considered 493 sections. So there was no pipe conditions. I hope I was able to find it out in excellent conditions. Only four sections were under the conditions of the good. Rest of that will be in a moderate, and this you can see the percentage. So 0.81 percentage, 0.81 percentage is hardly 0.81 percentage is in a good conditions. 36.51 percentage was in a moderate conditions, and remaining in the risky and the very risky conditions. So this is one type of the beauty of the fuzzy logic, where you were not having any idea how to start. Only you were having some data. You just see you were not having the data of the traffic and all, but some data you were having. So you have put up that particular data in a proper way, and finally you are getting or you are achieving your objective, whatever is you are interested. So this is the simple thing, fuzzy logic. So the two thing is very important if you are working with a fuzzy toolbox. So fuzzy toolbox is not having a copy paste command. This is the very important drawback of the system. You don't have a copy paste command, and generally we are very used to that particular command. We can't work without that copy paste command, but there is no option available. You have to work with a fuzzy toolbox. There is no copy paste command available, and the file is working with a import and export operation. So import means you have to get it in from the system, and export means when you have to save it. Second very important thing, whenever you are working with a MATLAB and you want to export as a Excel file, so in an Excel file you don't have to report any readings, means heading, just say age, BMI. You don't have to use any alphabets. Only number will work. And first you have to write down one simple problem where your Excel file will be converted into M file, because MATLAB is unable to read Excel file. When you want to work with a MATLAB, first you have to convert your Excel file into M file. So it's a very simple operation. You have to write down one line MATLAB programming, and that type of the help is available in a MATLAB help. So those who are interested in working with the MATLAB fuzzy toolbox, they all are requested to first read the MATLAB toolbox help given in a MATLAB help, and then you can proceed. So likewise, when we are totally blank, we don't have a data, we can work with the system and we can have a particular problem as far as the civil engineering or any engineerings are concerned. And at the last, I will be saying that computers are never good as a human. So generally, whatever the reasoning and the holistic approach we are considering, so for that only the human mind has to work. So you can't put the rules blindly, and for that you have to use your reasoning and the logical concepts. So don't completely trust on the computer, and don't feed the totally rules directly by the fuzzy toolbox. And computers is much better than the humans, so this is in processing the data and performing the complex calculations. Because if you work this complete the problem whatever I have discussed, so the complex problem, if I work without fuzzy toolbox MATLAB, then it's very difficult for me. So the finally I can say the fuzzy logic can be a useful tool for the development of the model where the reliable and the scientific data are not available. So thank you very much. If you are having any doubt, you can ask me, and I hope that all of you have enjoyed the session, and I think at least you understand the session, whatever I want to.
Thank you, ma'am. The section was really helpful. We'll take the questions now. Ma'am Ladon Pratapati is asking, could you please explain how to determine the function of a particular problem that we define?
So actually here we have to take the help of means the informations whatever we are having. Suppose I will be preparing a model. Uh, in which I suppose I work in a climate change program. So I have to predict, I mean, based on the rainfall data and based on the temperature data. Suppose I want to predict the water quality data. So in this type of the situation, you are knowing what will be the range of the rainfall of that particular basin or whatever is the temperature range, so that you can select. Now there are some of the engineering problem where the in general range we are knowing. So in that type of the situation, we have to consider that in general range whatever we are knowing. So if you are not knowing, if you are nothing, if you are not knowing anything, so in that type of the situation, you have to start with the taking opinion of the expert. But here your selections of the expert is very important. So you have to select the opinion, you have to select the expert of that particular field only. So you can't select the opinion, you can't select the experts in this type of the situation as the environmental or the transportation people. You have to select the particular people as an expert.
Okay, ma'am. Ma'am, I wanted to ask you this question. How do we decide which membership function we should choose?
So actually, it's a very important question, and this is the main the beauty of the system. So actually, there are so many consequences here, and the thing is, very important thing is you have to depend on the opinion of the experts. Suppose you are particularly a researcher, and you are asking me what will be the range of the particularly parameter like a very young. I am saying that according to me, it's a 0 to 25. So now I am very damn sure ki, okay, up to 0 to 25 is a very young age. But the same question you ask to some another person, some another expert, and he is saying that no, 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 up to 20 to 25 we may consider. So now here the range is coming up to 20 to 25. So in that type of the situation, you have to consider 20 to 25 again, because it's the range. Finally, you are getting the range.
Excuse me, ma'am. What you're answering is, I guess, about the range of the linguistic variables. My question was about the membership functions, like if how to decide whether we choose triangular or trapezoidal or Gaussian.
Yeah, I'm coming to that particular point. I'm coming
Okay,
to
ma'am.
that particular point. So when you are getting the range, particularly defined range, so in that type of the situation, it is always better to go with the triangular membership functions.
Okay.
Okay, but suppose you are getting only the range, but in that particular range, you don't have any variation. Suppose you just see the seven experts, and all of you have given 20 to 25, uh, 25 to 30, 30 to 35. So in that type of the situation, what you can do, you normalize the things, whatever is given, normalize the range, whatever is given. For normalization of the data, there are so many methodology available, and that you can select it. Now for normalizations of the data, so if your range is very nearer, means that the expert range is very nearer, so in that type of the situation, you may go with the triangular membership functions. But it is varying, highly varying. So in that type of the situation, always it is better to go with the trapezoidal membership. But again, this is a in some of the cases you may select the even as a trial and error, because fuzzy is a mathematics. So in that type of the situation, it may be possible that in some of the functions you may select the triangular membership functions, you may get the results model output very fine. But if you are selecting trapezoidal, you are not getting the output very fine. So in some of the situation, you may try with another alternatives also, and that may change your model output. So whatever is giving better, that also you can select, because it's a, right now it's a growing field. For all the type of the variables, you will not find any particular research paper where this type of the concept will be given. So you may select whatever you are working, you whatever you are researching, so that may be a useful for others. So you may have a trial and error options in some of the cases.
Okay, ma'am. Ma'am, what about the weights? How do we calculate the weights for the rules?
So actually here, whatever the problem I have considered, so in that I have not considered any weightage. I have considered all the parameters equal. Suppose I
Yes,
have
ma'am.
considered age and BMI, so I have considered the weightage of age is equal and BMI is also equal.
Hmm.
But when you are interested in calculating the weight, so in that type of the situation, you may select the weight, or you may calculate the weight with the analytical hierarchy process, AHP. So finding out the weight with the AHP, and then you may consider again in a rule. So when you are performing your rule, so नीचे आपको एक already option is given to you. So if you have a change, your weightage is changed, then that weightage you can carry forward in your rule editor. So if you are changing, then in that type of the situation, you have to put your weight, and accordingly you can go ahead with the system.
Okay, ma'am. Thank you,
Even
ma'am.
fuzzy HP is also possible. So there are even tools available in a MATLAB fuzzy AHP. So you first finding out the AHP weightage from the AHP, and that you can use it further for your fuzzy toolbox.
Okay, ma'am. There's another question from Mr. Shahi Kamidwani. He wants to ask, so basically fuzzy logic is used only when we have an idea about the output and we just need to quantify in linguistics. Can fuzzy logic be used when we don't have any idea of how output would look like?
Yes, you can use, but in that type of the situation, your maximum, your alternatives will be more, because you don't know. So you have to select. You have to go for the optimization. You have only one trial will not enough in that, because you are not knowing exactly your output. So you are not knowing how is your output, and in that type of the situation, you have to go for number of alternatives. You have to go for the fuzzy optimization, and out of that, whatever is the best, that you have to select. You can definitely go ahead, but your work will be increased in that type of the situation.
Okay, ma'am. Ma'am, Miss Shobna wants to ask, uh, ma'am, these and or operations can be used and things can be grouped using basic Excel and other tools. How fuzzy logic is advantageous and how different from them?
So actually, you can use it in Excel, but in Excel, this does defuzzifications and rule operator will not be there. So the logical operations will work, but here you are getting the aggregations of all the conditions. So it will be vary. A second very important thing in Excel, I think you have a restrictions. When you have a more input parameters, you can't go with Excel. And second very important thing is, when you are Excel, whatever the range you are specifying, again you have a limitations. In fuzzy, you don't have a limitations.
Okay, ma'am. There's another question from Mr. Mohammed Yasin. He's asking, isn't expert opinion also subjective? The unregulated nature of this theory seems a downside. Shouldn't it be regulated under a set of rules?
So definitely, experts' opinion may be considered as a bias in some of the cases. But the very important, that is why I have explained, your selection of expert is a very important and crucial operation. Second very important thing, suppose if you consider that this particular expert opinion is not matching with others, then you can filter it out. You have an option. Ultimately, there are so many systems right now, and there are so many engineering problems where we have to deal with a expert's opinion. So in that type of the situation, there are so many theories available where you can normalize, where you can omit, where you can filter out the opinion if you consider this is not best, or this is finally overleading my conclusions. So in that type of the situation, you may consider that thing. Second very important thing, the set of the rules, that also here the simple thing is, we have considered with our perceptions. But here also you may take the opinion of the expert. There are some of the experts for which you may get a wonderful opinion, and with the help of that you may change. Even one rule, if you are changing, it is also a trial and error. So here the beauty of the system is, you don't have anything and you want to work, then you can work. Always all the system is having a positive sides and the negative sides. So experts' opinion will be definitely, in some of the cases, you may have a biased opinion. So in that type of the situation, you may have a so many alternatives to filter it out. But instead of that, I think it is better, because you are getting the finally the output. So according to me, actually, there are so many systems where we are working with experts' opinion. There are so many tools and the simple mathematics judgment available for the experts' opinion theory. Uh, it's not like a particularly down training of the system, but in some of the situation. And second very important thing, where the reliable data are available, we don't have to use fuzzy logic. Where the unreliable data are available, in that type of the situation, only we have to use the fuzzy logic. So I think the opinion of the experts, the error you can minimize.
Okay, ma'am. Thank you, ma'am. Ma'am, there's another question. Ma'am, while we calculate the outputs using the fuzzy logic toolbox, do we have to give it the inputs in single rows? Like, can't we give it the data in the form of like multiple rows so that we get multiple outputs?
Yeah, you can get it, but in that type of the situation in a Excel, when you are means your reading of the Excel sheet by the MATLAB is very important. It is according to row wise or the column wise. So horizontally it has to read the data, or the vertically it has to read the data, that you have to specify. So once you specify, then you don't have any problem. But you require to give your one line program in between. The reading of the data, it will be in the form, it will be in a means column to column, or it will be from row to row, whatever the changes, according to that you have to consider.
Okay, ma'am. Thank you, ma'am. Ma'am, I think that's it. These are all the questions.
Thank you.
Thank you, ma'am. Thank you for joining us.
Okay. Okay, thank you.
Thank you, ma'am. So, Mohammed Yasin, but you wanted to ask, isn't expert opinion subjective? I would like to add something to this. If in case we use adaptive neurofuzzy inference systems, in that case, the rules and all, they are decided by learning and training the neural network. So I think that it is actually a downside for fuzzy. And if we use adaptive neurofuzzy inference system, that kind of takes care of this thing, which is a downside for fuzzy logic, because in fuzzy logic we do have to consider the expert opinion, but in NFIS we consider we train the neural network, and based upon that training and historical data, we get the fuzzy rules, and the membership functions all are developed. I wanted to add this thing to it. So I think that's it. Dr. Ikuda, uh, sir, are you there?
Yeah, yeah,
Yes,
yeah.
sir. So, should we finish the session?
You finish. Let you finish the session with any participant maybe wishing to tell something about the course.
Okay, sir. Okay, sir.
I finish it.
So, if anyone among the participants wants to say something, you can please write it down in the chat box, and then you can speak one by one. We will tell you who will ask you to speak. Yeah. Okay. So I thank all the participants for being a part of this short-term course. Thank you for abiding by the rules and patiently hearing all the lectures. A form for collecting the response of participants for the certificates will be mailed to all of you soon, and you'll be receiving the certificates as soon as possible. Thank you again for joining us. If any one of you wants to say something, you please write it down in the chat box, and we will ask you to speak then. Yeah, Mr. Mohammed Yasin, but if you want to speak, you can unmute yourself, and you can open your video also. Okay, I think, yeah. Yeah, yeah. Some people had to say in the feedback forms that they wanted a hands-on practice, but this session was not for that. We just wanted to give the people a basic idea of how AI or machine learning can be used for civil engineering applications. Hopefully, we will do such sessions in future, and we hope that you all will join us again. Thank you, Udyan Shrivastava. If any one of you wants to speak, I think Miss Shobna wants to speak. Yeah.
Yeah, it was really a wonderful session. I really learned a lot. Actually, basically, I don't have much idea about this artificial intelligence and stuff. I just know like there is something exists like that. But yeah, these sessions were like eye openers. I was able to get to know the basics so that I can build on it. It was really insightful, and for you people, organizers, you really done it very well. Ruhi, thank you
Thank
very
you,
much
ma'am.
for your support
Thank you
from
so
day
much,
one.
ma'am.
Like even for registration, you helped me a lot. Thank you very much
Oh, yeah, I
for the
remember
support.
you, ma'am, now. Thank you so much. So I think that's it. I don't think anyone else wants to speak. Yeah,
Yeah, yeah, you can wrap it up.
yeah. Thank you so much. Thank you, everyone. So, would you like to speak some words?
No, I just want to thank Sakiba and Rohi uh, for
Thank you, sir.
arranging this short-term course.
Thank you so
Thank
much,
you
sir.
very much. Thank you.
Thank you, sir. Thank you all.